All right. Good morning. So I'm super excited to be here for session 2 of Word Problems, No Problem. Today we are going to focus on finishing the additive schemas, and we're going to move to the multiplicative schemas. And my name is Sarah Powell. I met all of you last time. Very excited to be here with you. I put out my email address. At least two of you have already emailed me for different resources, so I'm happy to help you out as I can. I'm also on Twitter and only tweet about math things. And I've put the entire presentation and some handouts for today on my website. So if you visit sarahpowellphd.com and you click on presentations, and I'll also put the link right here in the chat box, you'll see there it says Virginia and it says session 2 presentation. So you can click on that and download the whole presentation, or session 2 handouts. You can download those and write on them, or hopefully you will also share this information with your friends. As we go along today, I will ask you a few times to refer to our Google Jamboard. A lot of people put some awesome attack strategies and total problems and different problems on the Jamboard over the past 2 days. So I'll put that link in there, and I'll put it in again when we refer to it. But you might want to have that open so that you can look at the different problems that your colleagues have been writing. All right, so for our handouts today, we are going to start with change problems. So last time we talked about total problems and different problems. We're going to start with change problems. But before we get to that, I want to go back to this idea that it's really essential to have an attack strategy. So we talked last time about a bunch of different attack strategies. I saw at least 5 different ones get added to the Jamboard with some consensus around R cubes and some consensus around UPS check. But as we get started this morning, I'd like you to say hello to some of your other colleagues. You're going to be placed in a breakout group. And so if you want to look at your Jamboard and look at the different attack strategies that you added and your colleagues added, I'd like you to take a few minutes to say good morning to a few of your colleagues, and then talk about what attack strategy you plan to use with your students, and then why. What is it about that attack strategy that would make sense for you as you teach 7th grade, or you as you support high school? So I think someone's going to organize our breakout groups here. So you'll be placed into a breakout group for a few minutes. So talk about your attack strategies and share those. And then we'll all come back together and we'll get started moving along with our change schemas. All right, so we're going to go ahead and continue. I hope that your group, we had a good discussion about attack strategies, and our group had different examples of them, but everyone was planning to use one, which is the really important thing. So beyond the attack strategy, last time we talked about teaching the word problem schemas, and we started off with the additive schemas of total, difference, and change. And we talked about total problems. So those are parts put together for a total. And on our Jamboard, we had lots of really good total examples here. This nice example about Lacey is a really straightforward total problem. I liked that one. These two down here about Anthony and Clara, these are total problems with more than 2 parts. And we didn't even talk about those on Monday, but we're going to talk about them today. But whoever wrote these understands that many times total problems have 3, 4, and sometimes 5 different parts. And then this problem over here about Ben has a total problem within it. That ends up being a multi-step problem. So I really like to, whoever shared this problem is really seeing how the total schema fits within a multi-step problem. We also talked about difference problems where we have greater and lesser amounts compared for a difference. On the Jamboard, I saw some really nice examples of difference problems. If I didn't share yours, it's not that I didn't think it was a great problem. I really just kind of shared some of the first ones that I read. And another example here, the pink one about Morgan, is also a multi-step problem that has a difference within it. And so as we move into middle school and high school, we don't always see a lot of total problems and difference problems that's just total or just difference, but often what happens is that these problems are embedded within multi-step problems. So today we'll now focus on the change schema. So here is our graphic organizer for total, difference, and change. So we'll start down here with change, and then we will head into the multiplicative word problems as well. So in a change problem, we have an amount that either increases or decreases. And these are substantially different than total and difference problems because in a change problem, something occurs over time. In a total problem, it's kind of well, it's a static situation. You know, you have these boys and these girls, and maybe you're asked to figure out the total number of boys and girls. And a difference problem, it's also a static situation. You just have these two amounts and you're comparing those amounts. But in a change problem, you have one amount and something's going to happen to increase that amount. Whoops, I'm sorry. Like in this story. So Shanna had $4. Then she earned some money. So here you can see over time, something happened. She earned money for cleaning her room. How much money does Shanna have now? But that story could also be asked this way. Shanna had $4. Then she earned money for cleaning her room. Now she has $7. How much money did Shanna earn? So again, still change over time. Or we might hear the story this way. Shanna had some money. Then she made $3 for cleaning her room. Now she has $7. How much money did Shanna have to start with? That last variation, probably a lot of you, if you've taught math for a while, you've run into that question before. How much money did you have to start with? How much was there at the beginning? That is a very, very classic change situation. But in all three of those stories, there's the same three components. There's a start amount, a change amount, and an end amount. In the first story, our job is to find the end amount. In the second story, our job is to find the change amount. And then in the last story, our job is to find the beginning or start amount. So if we are thinking about our questions to help students cue into, well, what type of problem is this? Last week last Monday, I'm sorry, we talked about total problems. We asked, are parts put together for a total? For difference problems, we asked, well, are amounts compared for a difference? And for change problems, we ask, does an amount increase or decrease? So if I'm using a word problem gesture, I hold out one hand because we have one amount. And when it increases, I pull my hand up. And when it decreases, I pull my hand down. Now, once we decide a problem has a change problem, is a change problem, we could use the change equation. So we use ST plus for an increase or minus for a decrease, C, which equals the change, equals the end amount. Or you could use graphic organizers. Both of these graphic organizers are really emphasizing that change over time. You see those arrows there? So a lot of times change problems are really easy for students to interpret, much more so than total problems and difference problems, because they can see that this change is occurring. So we're going to solve a change problem. So I'm going to look at my handouts and we're going to work on problem E here under the additive problem type. And I'm going to click over here so we can solve this problem together. All right, so I see a word problem. And the first thing I'm going to do anytime I see a word problem is I'm going to bring out my attack strategy. And my attack strategy here is I'm going to use UPS check, but I know some of you are using R-cube, some of you are using RIDE. I saw that's a popular one as well. And remember, I like to write my attack strategy here on the page vertically so that it's really easy for me to remember. First, I understand the problem, then I make a plan, then I solve, and then I go back and I'm going to check my work. So let's understand the problem by reading it. A plant was 3 3/4 inches tall at the beginning of June. By the end of July, the plant was 9 1/8 inches tall. How many inches did the plant grow in 2 months? So in this story, I have to focus on the inches of the plant. So I'm going to underline inches. So I really focus on numbers that deal with inches and really anything that deals with inches. And so I have a basic understanding of the problem. So I'll check off the U and now I'll make my plan. Now I'm going to make my plan by schema. So I ask myself, is this a total problem where parts are put together? Is this a difference problem where amounts are compared? Or is this a change problem where we have one amount that increases or decreases? Well, if I think about it, I've got one thing, it's this plant, and the plant's height is increasing. So I'm going to solve this as a change problem. And because there's an increase, I'll write a plus sign right there to show the increase in the height of the plant. All right, we've got our plan. Let's solve this problem. So what we do is we go back and every time you see a number, you should stop, ask students, well, do we need this number to solve this problem? And here I would ask, does it tell me about the start amount, the change amount, or the end amount? So here, 3 3/4 of an inch, that tells me about the start amount. We don't know the change amount, so I could mark that with a question mark or X or maybe I for inches if we want to do that. And then my end amount is 9 1/8 of an inch. And I'm going to go a little bit faster here solving this problem here today, just so we can get to our other problems. So now I want to figure out, well, what's the value of this question mark? If I want to start to introduce some algebraic ideas to students, and hopefully a lot of you are doing that, I might want to talk about balancing the two sides of the equation. So here I'm going to subtract 3 3/4 from both sides to isolate the question mark. And I believe that if I do all of the math, that my plant grew 5 3/8 inches. So I'd like to put my label there. So I've solved the problem, and then I want to go back and check my work. So I could check my work by adding 5 3/8 to 3 3/4 to ensure that that's 9 1/8. I could subtract 5 3/8 from 9 1/8 to make sure that that's 3 3/4. Several different ways to check this problem, but I want to make sure that I've checked the problem in the end. So that's an example of a change problem in which we have a change increase. But there are also examples, and you're going to solve one of these in just a minute, where we have a change decrease. So in a story like this, Reese baked 9 cookies, then she ate 2 of them. How many cookies does Reese have now? So we have one amount, that's her cookies, and something's happening to decrease those cookies. Here's an example where we have to figure out the change of cookies when Reese eats some. And here's an example where we have to figure out the start amount when after Reese ate 2 cookies and now has 7 cookies left. So in all 3 of these stories, there's the same 3 components: a start amount, a change amount, and an end amount. And so that's what makes all of these change problems. They are not different types of problems. All of these lumped together to represent the change schema. So if we have a decrease, we can still use the same equations, the same graphic organizers. And so I'd like you to think about that as you solve problem F. My font here where the problem says a balance of, that's negative 2480. So I want to introduce how we can use a negative integer with the change schema. So I'd like to give you just about 60 seconds to read through this problem and figure out how you could help students solve this as a change problem. All right, so hopefully most of you see that this is a change problem. We have a start amount, and then she spends some money, so there is a decrease, and then we end up with a negative balance. And so I bring in this story here to show that these schemas work with, we've already looked at them with fractions with our plant example. Here we have an example with positive and negative integers. So I believe if you solved this problem, I think how much money did she have to start with? She probably had $110.89. Okay, so excuse me. So on the Jamboard, when we get to the end of today's session, I will ask you for an example of a change problem. So as we move to the Jamboard, and I'll just show you this quickly for anyone who hasn't been on there yet. If you go to the top of the screen and click on next frame, here I can see great examples of total problems, lots of really great examples of difference problems. And then what I'd like you to do between now and Friday is add your own example of a change problem. So then as we go through the week, we're really accruing our knowledge around these different schemas, and you see how we operationalize these change problems in different situations there. So we'll go ahead and move back to our presentation. So I want to talk about these 2 problems at the bottom of our additive word problems handout. And a few of you have already alluded to what happens with problem G. So here with problem G, Sam mows lawns and made $560. She made $95 Monday, $135 Tuesday, and $70 on Wednesday. How much then did she make on Thursday and Friday? So some of you already gave these total problems where we have multiple parts. So this one actually has 5 parts, so I could use P1 plus P2, actually really 4 parts, P1 plus P2 plus P3 plus P4 equals T. Most often, total problems have 3 parts, but if you notice this, when I talked about total problems, I never said 2 amounts that are put together for a total, but I just said amounts that are put together for a total, or parts that are put together. So as you are all indicating, a lot of these total problems are going to have more than 2 parts. And in the same way with change problems, you can use that change equation to show 2 decreases, 2 increases, maybe an increase and a decrease. So here we had $70, then she spent some money, and then she saved some more. So more often than not, change problems end up having multiple changes in them. A lot of questions will deal with money with multiple changes. I've also seen a lot of questions with temperature. You know, that's this temperature in the morning, and then it gets hotter, and then it's colder. What's the temperature now? And so be prepared to be able to use either your change graphic organizer or your change equation and have flexibility with it to incorporate multiple changes. So problem H here is a multiple change problem. So now it's schema quiz time. So I'm looking at the chat box, and so I'm going to show a problem and wait about 10 seconds. But then if you have an idea as to whether this is a total difference or change problem, just go ahead and write it in there in the chat. All right, so what type of problem do you think this is? It's either total, difference, or change. All right, if you have a suggestion, you can go ahead and put it in there now. Nobody wants to be the one that answers, but Amy and Dana, they just went for it and they're right. It is a change problem, and this is one with multiple changes. So we start with some stamps, his number of stamps decreases, and then or he increases and then it decreases. So a lot of change there. The interesting thing is this has one of those key words in it, right? So I see that word total, and that's one of the reasons that we can't say to students, oh, whenever you see total, that means you would add, because that would not lead you to a correct problem solution for that. What about this problem here? Now we see a pictograph that has to be interpreted, and there's some halves of those cylinders, which it complicates the interpretation. But the question down there at the bottom tells it, really cues us into, well, what do we have to figure out? Do we have to figure out total, difference, or change? Yeah, so Jessica, you kind of probably saw that. How many more pounds of plastic did I recycle in July than April? So we're really figuring out the difference between those 2 months of recycling. And then with this one here, another one that we have a graph that we have to interpret. And so a lot of times, remember as we talked about Monday, a lot of times the complication with word problem solving is the setup. But here the question is, what is the total number of packages Mr. Conley delivered on Monday and Tuesday? So Dana and Terry start to say total. So yeah, here we have to figure out the total number of packages. But do note we have a lot of irrelevant information. We don't need to focus on Wednesday or Thursday or Friday. So this is one of those problems where we have to be really picky about what information we are going to use. Great. So as we think about that problem solving, remember we want to have our attack strategy and we want to focus on those schemas. And we've talked about the total difference and change schemas. And so now we are going to get into the equal group schema, the comparison schema, and the schema that represents ratios and proportions. So these are what we call the multiplicative schemas. These are schemas in which students will often multiply or divide to then use this schema. And these are introduced in the late elementary grades, and then they hang with us for really the rest of our lives. The equal group schema is a really popular schema. The comparison, a little bit less so. We don't see it used at much, but it is important for students to understand it. And then as we head into middle school and high school, lots of stories related to ratios and lots of situations related to proportions. And we can use the proportion schema to think about unit rate, to think about percentage percentages. There's just lots of ways that that schema can be applied again and again. And often, as we'll talk about on Friday, we start to see these multiplicative schemas combined with the additive schemas in order to solve multi-step problems. So we are going to look now at a new graphic organizer. It's in the presentation. It's also in the handouts that are available on the website. It's just a PDF that you can download here. And we are going to focus on these three. I will say that there is a fourth multiplicative schema that is sometimes seen, and it's a combination schema where you're thinking about combinations of shirts that go with your combinations of pants. It's pretty infrequently seen on high stakes tests, so I'm not going to spend time on it. But if you want an exhaustive list of the schemas, I would add combinations in here. But for 95% of the problems your students are going to solve, these are going to be the three multiplicative schemas that they're going to see regularly. So let's talk about them. So the first one we'll talk about today is the equal groups schema. Here we have groups, and we have a number in each group for a product. And so if I'm using my gestures, which we really like to do, I like to hold out my hand to kind of show a group, and then I use my other hand to drop in a certain number into each of those groups. Your very classic equal group situation is this. Mark has 2 bags of apples. There are 6 apples in each bag. How many apples does Mark have altogether? So that's like your entry-level equal groups story. But equal group stories can also be these. Mark has 12 apples. He wants to share them equally with his 2 friends. How many apples will each friend receive? Or Mark has 12 apples. He puts them into bags with 6 apples each. How many bags did Mark use? So in all 3 of these stories, there are the same 3 components. We have groups with an equal number in each group, and we have a product. In the first story, our job is to find the product. In the second story, our job is to find the number that are in each group. And in the third story, our job is to figure out the number of groups. And so some teachers might say, well, one of these is multiplication and the other 2 are division. Remember, we don't want to describe word problems strictly by their operation, because that's not always the way that every kid in the class will solve it. But instead, we want to dig deeper and really think, well, what's going on in this story? And the situation that all of these stories have in common is that they're thinking about equal groups. So once we decide that something is an equal group story, we might want to use an equation. We'll either use G times N equals P. If kids have already done G with the difference problems, we'll use GR times N equals P. So the groups times the number in each group equals the product. There's different graphic organizers out there. I just pulled the one that's on our graphic organizer about the different schemas, but I've seen teachers have other ones to use for equal groups problems as well. And the consistent question that we want to ask to get students to cue into, well, is this a equal group situation, is, are there groups with an equal number in each group? So we're going to solve 2 equal groups stories here today. So on the handouts packet, I have a page that says multiplicative word problems, and we're going to solve problems A and B. I'll go ahead and tell you they are both equal groups stories. One is a little bit trickier than the other, but that's always good for us to think about. So I'm going to move over to my camera, and so we can solve this problem together. So I see a word problem right here, and it's a mix of numbers and words. And anytime I see a word problem, I want to attack that word problem. And I'm going to attack that word problem with my attack strategy. As I said before, I like to write it here, so it's easy for me to remember. A lot of classrooms, they might have like a bookmark, or you might have an anchor chart or some type of visual for students to refer to. Maybe they just get out their UPS check bookmark or their R-Cubes bookmark to use as they see this word problem. So I'm going to understand the problem by reading it. Miss Thompson sold 6 cartons of cherries at the farmer's market. Each carton holds 25 cherries. How many cherries did she sell? So in this story, I have to focus on she sold cartons of cherries. Each carton has 25 cherries. So I have to figure out the number of cherries that she sold. So I'm going to underline cherries. I don't have to underline cherries every time I see it. That starts to get distracting. I also, if I wanted to, I could focus on the cartons, but I really want to focus on the end result. I need to figure out the individual cherries that she sold. So I've got an understanding of this problem. Now I need to make a plan. So I can ask all my questions. I could say, well, is this a total problem? Are parts put together for a total? Is this a difference problem? Are amounts compared for a difference? Is this a change problem where one amount increases or decreases? Or is this an equal group story where I have groups with an equal number in each group? And I can see, well, I've got groups. I've got cartons and the cherries are in each group. So I'm going to solve this as an equal groups story. So I'll immediately write my equal groups, what we call equal groups equation. And now I have a plan to solve this as an equal groups story. So as I set up and solve, I read every time I see a number, I stop. 6, do I need 6 in this problem? Yes. Does 6 tell me about the groups, the number in each group, or the product? Well, 6 tells me about the groups. And I keep reading. Each carton holds 25 cherries. 25 is a number, so we stop. Does 25 tell me about the groups, the number in each group, or the product? Well, that tells me how many are in each carton. And so how many cherries did she sell? That's what we need to figure it out. I can mark it with a C, question mark, X, however you want to mark it. I now put in my symbols, and we will solve for the number of cherries. So 6 times 25, 150 cherries is a great label to put on there. I've solved the problem, and then I need to go back and check my work. 150 divided by 6 is 25. Check. We have solved this problem correctly. Now, speaking of this label right here, I know that some schools are doing this, and I think the expectation in Virginia is that students write about mathematics in some ways. And so really connecting the vocabulary of the story, and we've even had teachers encourage students to say, you know, Miss Thompson sold 150 cherries, you know, something like that. So if you're really trying to connect math writing to mathematics and getting students to think about math in complete sentences and with ideas, and then students could also even write about how they solved this problem, you know, what was their process and their equal groups interpretation and so forth. That may not be like all of you want to do, but that's one of the reasons we really try to connect a label to a numerical response and then get students to start to think about how to speak about that or write about that in sentence form. So I'm going to pause for about 2 minutes or so, and I want you to look at problem B here about Jane. So she bought some light bulbs, and they come in packs of 4. This is an equal group story. It's a little bit of a different setup, but I'd like you to think through, how could you set up this story? Do you want to use an equation? Are you going to use a graphic organizer? But how could you help students solve this problem? All right, so here you can see we are given the product here of 112 light bulbs, and they come in packs of 4, so those describe the number in each group, and then we have to figure out the number of groups in this story. So hopefully all of you solved this problem well and figured out a good way to help your students solve this type of problem. And I will say that we do a lot of evaluation of the different types of word problems that we mostly see on high stakes tests. And this is a very common equal group story. Most students can answer problem A, you know, the cartons of cherries, you know, how many cherries did she sell? That problem's a lot more straightforward. These are a little bit trickier. They involve more interpretation and more understanding of the problem. And so really trying a lot of equal group stories where the groups are missing, trying a lot of equal group stories where the number in each group are missing. Those are pretty common types of word problems that we will see students be asked to solve in middle school there. Okay, so on the Jamboard, what I will ask for you to do is figure out like what is an equal group story. So start to think about that, and then between now and Friday, you will share an equal group story with our whole group. So now we'll talk about now we'll talk about comparison problems. And so if you go to this graphic organizer, I hope you'll come back to this and you could share it with your students or share it with other teachers. But in each of these, we have a definition of the schema, graphic organizers that you could use to solve the schema, and then different examples, and then different variations. So here you could see as a variation at the end of a comparison schema with related to a fraction. In this one, I wanted to just point this out. I'm going to talk mostly today about comparison problems where the product is unknown, because almost all of the time when we see a comparison story, it's that. You may find a comparison problem where a set is unknown or where the number of times is unknown. They are much more unusual, but I've put those variations here. I haven't included them in my slides today just because they are so unusual. But if you wanted to know, hey, what are the other variations within a comparison story? They are on this graphic organizer here. Okay, so in a comparison problem, we have a set that's multiplied a number of times for a product. And our very common comparison story is this. Jill picked 6 apples, Mark picked 2 times, or a lot of times you'll see that it's twice as many apples as Jill. How many apples did Mark pick? So here we have that set. Here our set is our Jill's apples, and then that set is multiplied a number of times. So again, this is the one that if you find a comparison schema, which are out there and occur pretty regularly, almost all of the time the comparison schema will be this type of question. So when we think like, oh, that's a comparison problem, well, how can we solve it? Well, you could use a graphic organizer. We'll use this equation, S times T equals P. So a set multiplied a number of times equals a product. And our question is there a set compared a number of times? And I'm going to solve this problem, and I'm going to talk to you about using a number line to solve this problem. It's often a really good visual that might actually end up being your graphic organizer. So if I use the gesture, I say, is there a set? So I kind of hold out my hand, and I have that set kind of bounce along my fake number line that's in front of me. So we're going to look at problems C and D. So I'm going to solve problem C and then give you a minute to think about solving problem D. So let's do problem C here together. All right, so I see a mix of numbers and words. That's a word problem. So immediately I want to get out my attack strategy because I'm going to attack this problem. I understand the problem by reading it. Enrique has 2 times as many pencils as Ava. Ava has 6 pencils. How many pencils does Enrique have? So here in this story, I have to focus on pencils, and I'm going to focus on the pencils of Enrique. So if I wanted to underline Enrique, I could, but again, be very picky about what you encourage students to either underline or circle or highlight, because again, as we talked about on Monday, often we'll ask students, well, underline the important information, and what will they do? They would do something like this. My underlining is not great, but that's exactly what they would do. And that's not what we want students to focus on here. So I've focused on the pencils for Enrique, and I've got a very basic understanding of this problem. Now I need to make a plan. Well, is this a problem where I have groups with an equal number in each group? Or is this a story where I have a set compared a number of times? Well, here I have a set, I have Ava's pencils, and I have to compare that a number of times. So this is a comparison problem. So I'm going to go ahead and write my comparison equation right here, and now I've got my plan. So you can see easily here how we take that attack strategy and we combine it with a focus on the schemas. Now I could also think about drawing a number line here, and I'm actually going to do that to help me solve this problem as I get my numbers set up there. So Enrique has 2 times as many pencils as Ava. 2 is a number, so we stop. I do need this in this problem, and I would ask, does this tell you about the set, the number of times, or the product? Well, here 2 tells me about the number of times, so I'll go ahead and write it there. And Ava has 6 pencils. 6 is a number, so we stop. Does 6 tell us about the set, the number of times, or the product? Well, 6 tells us about the set, and our job is to figure out the product. So I'm going to multiply 6 times 2. So if I think about this number line, well, I think of one set from 0 to 6, but I have to do 2 sets. So then I am now at 12. So 6 times 2 equals 12. And what would be a good label for that numerical response? Pencils, which is what I underlined initially. So now I've solved the problem, and then I could go back and check my work. 12 divided by 2 does equal 6. So I have checked my work. So there's lots of different visuals you can bring in here. Some students might want to use a multiplication chart to help solve this problem. Hopefully a lot of your students already know that 6 times 2 is 12. That's not always a guarantee. But you can see the things that are consistent. I'll just look at these two problems here. My X over there is messy. I'll cross that out. Look how these are different schemas. We use the same attack strategy. And then we have similar strategies to solve this. This is an equal groups equation. This is a comparison equation, but I'm still plugging in the information. I'm still solving for an unknown. I still always write a label for my numerical response. And so there's a lot of consistency with how we solve these problems, and that's really important for students. You don't want to have one totally different strategy for solving this problem and a totally different strategy for solving the comparison problem. They're really very similar, except that the schema differs among these problems. One other thing that I just want to make a note of here before we go on and have you practice your problem is when I talked about these numbers, I said, well, 2 is a number, so we stop. Do we need it in this problem? Okay, yes. And then be very consistent with how you ask, well, is it the set, the number of times, or the product? And when I got to 6, I asked the same question. Is it the set, the number of times, or the product? Even though we already knew that the number of times is 2. So really think about the questions that you're asking and asking them consistently, because those are the questions that we want students to internalize. Every time they see a number here, they should be thinking, well, is that the set, the number of times, or the product? So be consistent with your language and really make students think about that, even though in that one it was pretty obvious that 6 was not the number of times. So I'd like you to look at problem D for a minute. So I'll move over back to our presentation and click on problem D. There we go. So this one is about Susan and Mo. So if you would like to go ahead and solve this problem, it is a comparison problem. I'll tell you that to get us started, but think about how you could solve this problem. All right, so here we can see 18 times 7, so 18th are set multiplied by 7. So that would help us with the number of books for Susan. So as we move toward Friday, I will ask you to visit our Jamboard, and I will share that link here as we go, but I will ask you, what's an example comparison problem that you could see your students solving? And so I'm looking at our clock. I want to start the problems that are related to ratios and proportions. We'll probably not finish all of this today, but it'll be a great place to pick up on Friday, and then we'll launch into multi-step problem solving, which I'm really excited about here. So for this schema, we might end up using ratios or proportions, but what we're going to do is we're going to describe different relationships among quantities. So a very common problem that we would see here is Sally typed 56 words in 2 minutes. At this rate, how many words did Sally type in 7 minutes? So here in the first sentence, we're talking about, well, words to minutes. And then to figure out, we have to figure out, well, words to 7 minutes. So 56 is to 2 as what is to 7. We also see stories like this. So Margarita baked cookies and brownies. The ratio of cookies and brownies was 3 to 5. If she baked 25 brownies, how many cookies did she make? So here we're thinking like, well, 3 to 5 is the same as what to 25. So there's also, as I said before, unit rate. So, if 3 packages cost $24, how much does 1 package cost? And percentages as well. So there are different graphic organizers that you might want to pull in here. The one on the left is really common and really works very well most of the time. The one on the right, Asha Jachandra and her research team will use in middle school, especially if it's just thinking about a part to whole ratio. So you're welcome to use either of these or come up with your own. And a lot of times we'll also just use equations here. So that's what I probably will use one of the graphic organizers today to shake it up just a little bit. So as we add to our collection of questions, are there groups with an equal number in each group? Is there a set compared to number of times? Or are there relationships among quantities? If this is to that, then this is to that. That can be kind of a cueing question to get students to think about, is this a ratios or proportions problem? So we're going to look at some problems, and I think we're going to solve one today, and we'll pick up with the others as we come back on Friday. But we'll look at problem E about these blueberry muffins, which seems very appropriate to talk about on a Wednesday morning. All right, so I see a word problem. I see a mix of numbers and words. Immediately, I want to attack it. So I get out my attack strategy, UPS check. There we go. And I need to understand the problem by reading it. The number of blueberry muffins that a baker makes each day is 40% of the total number of muffins. On Monday, the baker makes 36 blueberry muffins. What is the total number of muffins the baker makes on Monday? All right, so we need to figure out the total number of muffins. So I'll underline muffins because I want to think about quantities that talk about the muffins. So I've got an understanding that I have to figure out the total number of muffins that she's made if she's made 36 blueberry muffins. Now I need to make a plan. Well, is this a story where I have groups with an equal number in each group? No. Is this a story where I have a set compared a number of times? No. Is this a story where if this is to that, then this is to that? Yeah, 40% is to 100%, then 36 would be to something. So I'm going to solve this as a proportions problem. I'll go ahead and draw my graphic organizer here very quickly. And I'm going to solve this as such, as a proportions problem. So now I'm going to solve it. So she bakes 40% of the muffins each day. So 40%, so 40 of 100. So if she makes 40 is to 100. So you can see how I can interpret my percentage there. And that would be as 36 is to question mark. If I want to put this into equation form, it might look something like this. And so there's several different ways that we can attack solving this problem. But if I do all of my math, I can see that question mark equals 90. And a good label would be 90 muffins. So you can see I've solved the problem, and then I can go back and check my work any number of ways just to make sure that I have checked my work. But I've got my attack strategy and I've got my schema, and so I'm doing all of the same stuff. Now this is a problem that has a percentage in it, and I'm comparing 40 to 100 as 36 is the question mark, but my process for working through this problem is the same. And so we'll pick up here with problems F, G, and H. H is actually a multi-step problem, which was our transition into multi-step problem solving. So we'll pick up there with that on Friday. But as I look at our clock, I just want to wrap up today and give us a little time to think about our, oh, well, I don't want to show the quiz. Oh, there we go. All right, so let me come back here real quick. All right, so for Friday, I want us to be really reflective about all of these different word problem types that we have talked about. So we've now introduced change problems, and then today we brought in equal group stories, comparison stories, and then ratios or proportion stories. So for Friday, I would like you to visit our Jamboard link. I will go ahead and put this link, if you don't have it already, I will add it to the chat box just one more time. And this Jamboard, I'll leave it there for a while so you can go back and refer to it after you attend the sessions this week. But go to our Jamboard, and I'd like you to contribute to write a change problem. And if you haven't used the Jamboard before, right underneath this arrow emblem is a little, looks like a sticky note. Just click on the sticky note and write your change problem in the sticky note. And then go to the next page. What would an equal group story sound like for you and your students? And then tell a comparison story, and then then tell a ratios or proportion story. So give us an idea of what your students are solving in terms of these schemas. And then on Friday, we'll wrap up ratios or proportions. There's a little bit more that I want to talk about there and some of the different variations of these schemas. And then we're going to do a lot of work on Friday with multi-step problem solving. And so some of those might be a multi-step problem where there's two differences maybe. those are a little unusual, but I have one example of those. But a lot of these are now going to combine schemas. So first you have to figure out, use the equal group schema, and then something changes. Or first you have to figure out the difference, and then you're going to use the equal group schema. So now we're going to see how these start to combine in multi-step problems. And I'm going to bring in a lot of examples from middle school. So you're going to do quite a bit of problem solving on there for Friday. So if you do have any questions between now and Friday, please feel free to reach out to me. There's my email address. I'm also on Twitter. And I will be posting all of the materials for Friday tomorrow. So if you want to head to the website early and download those, you're welcome to do that. But I will say, I think we're going to finish exactly on time. So thanks so much for joining in today. And I look forward to wrapping up and talking about multi-step problem solving with you all on Friday. So I hope you have a good rest of your morning.